Juan, this term space-time is become very common among scientists, meaning an integration of space and time. Intuitively, that seems almost nonsensical.
I think one of the most important ideas is the idea that space-time is not a static concept. It's not some background where particles move. It's not a stage where actors move, like the particles are the actors that are talking, and the stage is fixed. The stage is not fixed. The actors modify the stage. And so space-time is modified by particles. So when you have a heavy particle, it curves space-time. So space-time can be curved. If you shake a particle, it will emit a wave of space-time. So if space-time is a somewhat strange concept, a wave of space-time is also very strange. But, well, this theory of general relativity is called, it's a theory of gravity. It's also tested in many situations, and we believe it's basically right.
So now we have space-time being relates to matter, and that matter curves space-time, and space-time gives matter its gravity.
Yeah, it gives matter the space on which it moves. Yeah. So where the matter moves depends on what the matter is doing, because it curves space. And it's just telling us how matter can move. Matter can move in this curved space-time. And so matter follows the shortest sort of trajectories in the curved space-time. So we see the Earth moving around the Sun. And that's not the shortest direction in space to go between 2 points opposite to the Sun, for example. But it's the shortest direction in space-time once we include time in the game. So it's counterintuitive. But
so how has this concept of space-time enabled us to understand the universe? The cosmology, the beginning of the universe.
Right. A fundamental fact is the universe is expanding. So this is the most fundamental fact of cosmology. And this is possible because space-time is dynamic. So we needed this theory of dynamic space-time. And the expansion of the universe also tells us that the universe was hotter in the past. And so particles were excited at higher energies and so on in the past. And things that happen at short distances in the past make an imprint on long distances in the universe. So this expansion of the universe also unifies the small distances with the large distances. So it's a very important fact in cosmology.
How has the latest theories in physics, particularly string theory, affected our understanding of space-time?
You have matter on one hand and space-time on another, and they are completely different. So matter is the thing that moves in space-time, and while you're on the other hand, you have space-time, which you describe in a purely geometric way. But string theory sort of implies a unification between space and matter. So small ripples of space-time, which is the graviton's quantum of gravity, is the same thing as a quantum of matter, so as, let's say, an electron. And both are described in terms of a single object, a string. So the string oscillating in different ways could be a quantum of space-time or a quantum of matter.
So we're saying then that you can actually unify not just space and time, which is weird enough, but now you're unifying space-time with matter?
With matter, yeah. That's the idea, that the two things are basically related in string theory and are the same thing. And the same underlying thing.
So the same thing manifests itself in two separate ways? One is space-time through the graviton, which is the quanta, the bit, the quantum of gravity in space-time, and the other is the photon or the
electron
in matter.
Yeah, exactly.
So but they're related to the same thing.
Yeah, the underlying physical reality of both is the same. It's this oscillating string, and that's one of the beautiful aspects of string theory, that it unifies space-time with matter. In order to describe the very early universe, you need this unification between matter and gravity, because the expansion of the universe can create matter, can create particles, and you need to describe both in a common language.
We just don't know if it's right yet.
We don't know whether it's right.
But something that, whatever will unify it, will probably have the elements of simplicity and beauty.
That's our hope. That has been the lesson of history, if you wish.